Alright, antiderivatives day 2 should be pretty quick. You should have the ability to get most of your homework done in class today. We're just going to go over some of the more complicated or the less straightforward ones that appeared in your homework last night and will appear in tonight's homework as well. Just to review, remember the fundamental theory of calculus for indefinite integrals says that the integral of some function, little f of x dx, is equal to big F of x plus c, where big F of x is the antiderivative. So we said that the integral is the antiderivative plus c. For most of your homework problems last night, the unpower rule was pretty easy to apply, right? We learned yesterday that if I was trying to integrate some function k x to the n power dx, that would be equal to x to the n plus 1 power with k over n plus 1 being the coefficient, and then I add on my plus c. Some of the problems last night were a little bit more complicated. They weren't as straightforward as let's just reduce the power rule. But the only thing that you needed to do differently was to simplify or apply a little bit of algebra before integrating the problem. For example, if I wanted to integrate x plus 1 over the square root of x, that's not as straightforward as let's just do the unpower rule. Let's just find the antiderivative. It needs to be rewritten first. I need to think about it and simplify and put it in a more calculus-friendly form. So in order to do that, the first thing I'm going to do is I'm going to separate these two things, and I'm going to think about this as the integral of x over the square root of x plus 1 over the square root of x dx. And then I'm going to rewrite that as the integral of x to the 1/2 plus x to the negative 1/2. And that is something that I can find the antiderivative or do the unpower rule to. That's going to be equal to x to the 3/2 with 2/3 as my new coefficient plus x to the 1/2 with 2 as my new coefficient plus c. So sometimes I gotta move some stuff around. I gotta do a little bit of algebra and get it in a form that I'm more comfortable doing the reverse power rule with. A problem like this presents issues for us because we didn't do anything with multiplication. We didn't learn the unproduct rule yet. So this isn't in a form that I can apply my antiderivative knowledge. But I can use some algebra skills to put this in a more calculus-friendly, unpower rule-friendly form. I would do that by simply foiling these two binomials, and then doing the reverse power rule or finding the antiderivative of each monomial separately. This problem presents the same sort of issues, except obviously it's not a foiling problem. For this, I would just distribute that x squared prior to finding the antiderivative, and I would rewrite this as 3x to the 5th plus 4x squared dx, and then I could find the antiderivative, which would be 1/2 x to the 6th plus 4/3 x cubed plus c. So nothing really new today, still finding the antiderivative. I just wanted to address those harder problems where you have to do algebra, whether it be foiling, distributing, or simplifying prior to finding the antiderivative. You should have enough time to get most, if not all, of section 4.1, 10 through 34 even. I also want you to go back on the odd section we did yesterday, and if you skipped any because you didn't know how to do it, you should now be able to go back and do those problems. So go back and take a look at the ones that you skipped from last night.